Hello everyone. In the last session, we studied about the kinetics of cationic chain polymerization. Now, let us know about the anionic chain polymerization. First, let us know about the anionic chain polymerization. What is this anionic chain polymerization? It is a type of ionic polymerization, and here the initiation begins with the attack on the monomer by a negative ion. So you know that anion means negative ion, right? So the initiation begins with the attack on the monomer by negative ion, and the propagation is carried out by the carbene ion. So this is the anionic chain polymerization. Then where does the negative ions or the anions will come from? They are obtained from the initiators. So usually the initiators are organoalkali compounds such as butyl lithium, triphenyl methyl potassium and ethyl sodium, and we can also use the alkali metal amides such as alkoxides and hydroxides also. So the monomers that can undergo anionic polymerization are isobutylene, butadiene, isoprene, styrene and acrylonitrile. Fine. Now let us discuss the mechanism of this anionic chain polymerization. As usual, in the chain reaction or chain polymerization, the same steps will be followed. The steps are initiation, propagation and termination, right? So the first step is initiation. Here what happens? The anion obtained from the initiator attacks the pi electron pair of the monomer. Fine. So then it leads to the formation of a carbene ion. Thus the polymer chain growth is initiated. See here in the reaction. So this is the anion obtained from the initiator, right? R minus, we have represented it as R minus. So this attacks this carbon and the electron pair gets shifted to the further end, right? So leading to the formation of carbene ion. See here, the carbon carries the negative charge, that is why this is known as carbene ion. Fine. So this is how the chain growth is initiated, right? Then the second step, it is propagation. So what happens in propagation? The successive addition of monomer molecules takes place. So the carbene ion, which is formed in the initiation step, attacks the second monomer molecule. Fine. The negative charge is transferred to the farther end of the second monomer unit, and thus a chain reaction sets in. See here, this is the carbene ion obtained in the initiation step, and this negative charge attacks the second monomer molecule, and the negative charge is transferred to the farther end of this second monomer unit. Fine. Then it forms a product like this, and this takes up another monomer molecule. Likewise, the chain reaction goes on until all the monomers gets exhausted. Fine. So this is the chain reaction. Then the third step is termination. So here in case of anionic chain polymerization, the termination is not a spontaneous process as in the case of cationic chain polymerization. Here the termination occurs when impurities are present in the system or some strongly ionic substances are added deliberately. Otherwise, the termination do not occur by itself. Fine. Yes. So here in this step, the chain growth will be stopped when the impurities are present in the system. Fine. What happens? The chain gets protonated, thereby neutralizing the negative charge. That's all, the termination. So these are the steps involved in the anionic chain polymerization. Now let us know about the kinetics of the anionic chain polymerization. In the first step, that is in initiation, what happens? So this is the initiator molecule, and this decomposes to give a ion pair. So this is the ion pair formation, and then here this ion pair, the anion, this attacks the monomer molecule, and the rate constant of this reaction is Ki. So this is the initiation rate constant, and this Kd is the decomposition rate constant. Fine. And now let us write the rate equation for the initiation. So that rate equation is given by Ri is equal to Ki into molar concentration of M, that is molar concentration of monomer, into molar concentration of carbene ion. A minus antandre it is carbene ion. Fine. Call this as equation number 1. Then the second step is propagation. So what happens here? The addition of monomers one after the other, leading to the chain growth takes place, right? So here this is the carbene ion formed in the initiation step, and to this the monomer, the addition of monomer takes place. Fine. And the rate constant of this propagation step is Kp. So the chain growth takes place here. The rate equation for propagation is given by Rp, which is equal to minus dm by dt. You know that why we have written minus dm by dt, because this is the rate of change of monomer concentration, and the concentration of monomer decreases as the reaction proceeds. So the concentration of monomer decreases with time, right, as the reaction proceeds. That is why. So this rate equation is given by Rp is equal to Kp, that is the rate constant for propagation, or propagation rate constant, into molar concentration of monomer into molar concentration of M minus. So what is this M minus? It is the concentration of growing chain. So carbene ions iruttala, so that concentration of growing chain is represented by M minus. So call this as equation number 2. Fine. Then the next step is we have to write the rate equation for the termination step. So here, if the termination occurs by the added impurity, see here this Ha is the protonating agent. So this protonates the this growing chain. Fine. So when this gets protonated, this abstracts, the negative ion abstracts the proton from this protonating agent and form a dead polymer like this. Fine. So the K here, Kt is the terminating rate constant, and the termination rate equation is given by RT is equal to Kt into molar concentration of M minus, that is molar concentration of growing chain, into molar concentration of Ha, that is protonating agent. So call this as equation number 3. Now the next step is, as you know, we have to combine all these 3 equations, right? So how to do that? So that can be done with the help of steady state approximation. So according to steady state approximation, rate of initiation is equal to rate of termination. So equate equation number 1 and equation number 3. So these are those equations I have taken directly, and from these two equations get an expression for the concentration of growing chains, that is M minus. ಗೆ ನಮಗೆ ಈ ರೀತಿ expression ಬರುತ್ತೆ. So how to get this? So retain this M minus on one side and transferring this Ha and Kt to the other side, right? Then substitute this value of M minus in the propagation rate equation, that is equation number 2. See here. So when we substitute that value of M minus in the propagation rate equation, we will get this final equation, rate of propagation, or you can also call it as rate of polymer formation, right, which is equal to Kp into Ki by Kt into molar concentration of monomer squared into molar concentration of A minus, that is anion, divided by molar concentration of protonating agent, right? So call this as equation number 4. And what we can conclude from this is the overall polymerization rate, that is Rp, is second order with respect to the monomer concentration. Fine. Then so let us know about the degree of polymerization here. What is degree of polymerization? It is the number of monomer molecules present in the given polymer chain, right? And that degree of polymerization is given by this equation, that is dP bar is equal to Rp by Rt, that is the ratio of rate of propagation to the rate of termination. So write the rate equations of propagation and termination. So these are the equations, right? Then this M minus gets cancelled, so we will end up with this equation. Fine. So what this equation indicates is the degree of polymerization is independent of initiator concentration, right? Here there is no A minus term, isn't it? Anion term illa. That is why we can conclude this degree of polymerization is independent of initiator concentration. Fine. Yes. This is all about the mechanism and kinetics of anionic chain polymerization. Thank you.